In today's video, I'm going to be attempting to create a custom classification model using the OpenAI package in R. This video is going to be a little bit of a different format than my usual videos. Today's video is completely unscripted and unplanned. I'm not even sure exactly where I'm going to go yet with the code or even what dataset I'll be using. As always though, I will post all of the code on my GitHub and I'll put the link in the description. And of course, I'll edit out all the silences in this video. My name is Melissa Van Bussel, and I make videos about data science and R programming under the name GG-Not2. If you haven't already done so, please consider subscribing to my channel so that I can keep making videos like this. I know that I want to do a sentiment analysis classification model, and I think I might have found a dataset that should work well for this. Supposedly, this dataset has 25,000 highly polar movie reviews in the training set, as well as another 25,000 for testing. And then there's also additional unlabeled observations for use as well. I'm going to try to download this. Downloaded fairly quickly. Looks like there's a lot of files here though. So rather than this all being in a single dataset, it's actually composed of 25,000 individual files for the training data and then 25,000 individual files for the test data. So for my purposes, based on the documentation in the README, I should be able to just focus on these two folders for the training data. I won't need any of the URLs or the data that's provided for unsupervised learning. So once this finishes extracting, I'm going to go ahead and delete everything in this folder other than the negative and positive folder inside of the folder for the training data. That finished extracting, so I'm going to delete these files. Probably a little unnecessary technically, but it's a bunch of extra space. Okay, let's read in the positive reviews first. And I'm going to do this probably not in the most efficient way, but I'm just going to use a loop to do this. Just going to use the list.files function to get the list of all the file names that are in that folder, and then I'm going to loop over that and read each one in and put the results in a data frame. First, I'm going to initialize a blank data frame, and then I'm going to use the read text function. I have to load the tidyverse first, and there should be a function in there for reading text files. I don't know if that's the exact name of it. Let's see. Read txt. Looks like it might be read file. What do we need for that? I'm going to add a column for the classification, so whether it's a positive or negative review, and then I'm also going to add a column for the text itself. It doesn't like that I'm trying to use the word class as the variable name, so I'll call this classification instead, and I'll just set those to NA for right now. And then inside of this loop, I'm going to turn the temp.df into an actual data frame, and the classification is going to be set to positive, and the text will be set to what's currently stored in the value of temp.df. And then I'm going to use rbind to bind the existing reviews data frame with the temporary data frame. And this is very inefficient and a messy way of doing it, but it should work. And that finished running, but I accidentally forgot to assign that to a variable. So I will need to run that again. It just takes a couple of minutes. And I'm just cleaning up my script a little bit. Not a ton, but a tiny bit. So up here, I'm setting the folder path just to be the higher level folder for the training data. And then in here, I'm going back one level inside of the training folder to the positively labeled data. And then same idea in here, just going one level inside of the training data folder, but this time for the negative folder. Then I can just repeat what I did before, but for the negative reviews. And I'll just copy this loop and switch this all to say negative reviews and change the classification to negative. Oh, but then I also just need to modify the read file lines, because before, when I was deeper inside of the positive folder for my working directory, it could directly see those files, but here I'm just going to need to paste the working directory onto the start of this. And same thing down here, just paste on the working directory to the front of that string. And then I also need to put a slash in between the high level folder and the file name, as well as the name of the folder. And this time that should start loading. And as soon as that's done loading, I'm just going to make sure that I save the results into an R data file. Let's just take a look at this data set and make sure that it looks how we would expect. And it does. It's got 25,000 rows, 2 columns. The start of the data frame has the positive reviews and the bottom part has the negative ones. And then just based on the example notebook, it looks like our columns need to be renamed as prompt and completion. So I'll use the rename function from the tidyverse to rename the text column to be called prompt, and I'll rename the classification column to be called completion. And I'm not sure whether or not this matters, but I'm going to put the prompt column on the left and the completion column on the right, just like the example notebook. I'm going to reassign the reviews data frame to be the reviews data frame, but where the prompt column is relocated to be before the completion column. And then I'm also just going to resave that. I'm going to need to turn this into a JSON file. So I'll load the RJSON package, and then we can use this function. Let's just look at the documentation for it, and let's assign that to an object. And then we can use the write function to convert that object into a file. And following along with this notebook, there's a data preparation tool which will take a look at your JSON file and then tell you if there's anything that you should change. I'm going to do this using Python directly, just because I don't think this is implemented into the OpenAI R package at the moment. So I'm going to install the OpenAI package. I think I only have it installed in a virtual environment right now. So I just ran pip install upgrade OpenAI, and now I'll need to run this, but I think I'm going to need to change my directory in the terminal first to be in the folder where my JSON file was created. So if I just check where that file was saved, I'm then going to change my directory to go into that folder. So now that I'm in that folder, I'm going to try running what's in this notebook here. So it's OpenAI tools finetunes.prepare_data -f, and then the name of the file, which was reviews.json, and then -q. Okay, so it looks like that didn't work. It's telling me that I'm missing pandas. So first let's try installing pandas, and then it's very slow. Okay, so now that that's done, I'm gonna try running this pip install OpenAI square bracket datalib. I think that probably finished installing, so I'm going to try rerunning this line from before and see if it works now. Okay, so it looks like that worked. Here it's saying that there were 25,000 prompt completion pairs, and then it's saying that it's automatically detected that we're trying to fine-tune a model for classification, and then it recommends trying this model specifically, saying that it's going to be faster and cheaper. Apparently there are 96 duplicated prompt completion sets, and then it provides the row numbers of those 96. There's also 3 examples that are very long. Specifically, looks like they're longer than 2048 tokens. And then it's saying that the file that was provided doesn't contain a common separator at the end of the prompts. It points us to the documentation for preparing the data set. And then it also says that it should start with a white space character, again pointing to the documentation. And then it automatically does a few actions based on that feedback. So it went ahead and automatically removed those 96 duplicated rows. I didn't actually type that Y there, so it just did that automatically. It removed those 3 long examples. It added a separator at the end of every prompt and a white space character at the beginning of the completion. And then it also split the data into a training and validation set. And then it wrote the results to a new file, actually to 2 files. So there's one for the training set and then one for the validation set. And then here it gives instructions on how to use those files, but I'm going to try to see if there's a way that I can use the OpenAI package in R to do this. And then it's also just reminding us here that because it went ahead and added that suffix of the arrow to the end of every prompt, then we're also going to need to make sure that the prompts that we provide to the model after it's trained have that same format. And down here it's saying that once the model starts training, it'll take approximately 10 hours to train if we choose a Curie model, and it could be less if we go with ADA, which was the model that it suggested to us. It's also saying that there's a queue that'll take approximately half hour per job that's ahead of you. So honestly, this file looks like it's going to be way too big. I'm definitely worried about how much it would cost to train this model. And given that I'm really still in the learning phase right now, I don't think I want to train something this big. I probably want to scale this down quite substantially. So I think I'm going to do this again. So I'm going to pop back to RStudio and I'm going to significantly decrease the size of the data set that I'm going to use. So I'm going to assign reviews to be the reviews data frame, but I am going to use the sample frac function from the tidyverse. So I'm going to need to specify the proportion, and here I'm just going to do 5%, and that will give us a much smaller data set, and hopefully that would reduce the costs of doing this quite a bit. If I look at my environment pane, it looks like applying the sample frac function didn't actually do anything. So I'm just going to switch this to sample n, and then I'll change the proportion to instead say n, and I'll just manually tell it that I want it to be this size. Oh, and sorry, that argument should say size rather than n. Okay, so now that's much smaller. Let's try saving that file again. I'll go ahead and delete those files that were generated in the terminal, and then let's rerun this. Okay, this one seems much more manageable. So this time it is seeing that there's only 1250 prompt completion pairs, and this time it's much more reasonable. It's saying that it should take about 32.33 minutes to train. I'm a lot less worried about how much that'll cost. So I'm going to close the terminal now, and I'm just going to take a look at the documentation for the OpenAI R package, and we're going to be using the create_fine_tune function from that package. So it looks like we'll need to specify the training file, and optionally we can specify a validation file. We'll need the model, and then the other important piece of information that we'll need is our OpenAI API key. There's a few different ways to define your OpenAI API key, and if you've watched some of my other videos, you might already have yours defined as a system environment variable. So you can check that by searching for system environment variables in the search bar, and then if you go to environment variables, you can click that, and then if the OpenAI API key is already there, then you're good to go. If it's not already there, then you can add it. You can add it by clicking new, and then entering OpenAI API key. And then for variable value, that's where you would copy and paste your API key, which you can get from Googling OpenAI API, logging into your account, going to API, personal, and then view API keys. And you can create a new secret key from there. And of course, again, just a reminder to never post that anywhere online, because if you do post it anywhere, then other people can charge money to your account, and it also goes against OpenAI's terms of service. Alternatively, if you don't have it defined as a system environment variable, you can also use sys.setEnv, and looking at the documentation for that, you'll need to pass it as a named list. So you would type OpenAI API key equals, and then you would paste your API key here. And then to verify that it worked correctly, you can use the sys.getEnv function, and it should be whatever value you pasted there. Then from here, we can load the OpenAI package, and let's attempt to use this function. I'm going to just copy and paste this example directly from the documentation, and then we can modify it as we need. I'm going to take a look at the documentation for the upload file function. So this first argument here should be the file path, which is going to be this file name right here. So this is the training data. And the second argument here is called purpose. And then similarly for the validation data set, the first argument is the file path. And again, we'll set the purpose to be fine-tune. And let's run both of those. And then there's not really much that we need to change in here other than it looks like we'll need to change this classification _positive_ class. If we take a look at the data frame that we started with and we look at the completion column, that's what's going to tell us what we should put for that value. So here, the positive class in our case is going to be considered this value. So it's literally just going to be positive in this case. But we do need to put the space in front of it. And remember when we were in the terminal and it was asking us if we wanted to put that white space in front of every single completion. And we said yes to that because that's recommended. So here the documentation is just reminding us that we need to put that white space character in front of that value. I'm going to go ahead and attempt to run this. Hopefully this doesn't cost too much money. For some reason that ran extremely quickly. I don't really trust it. There's also some other functions in the OpenAI R package documentation that might be useful here. So there's this retrieve fine-tune function. I'm going to copy and paste from the examples. The first part of the examples here are exactly what we already saw with the create fine-tune function. So if I run this line, it still says pending. I'm not sure exactly how long that queue will be. And then apparently it should take somewhere around half an hour to train. My guess is that I'm just going to need to leave this be for a couple of hours and then come back to it. So I'll just stop the recording for now and then check on this down the road and see if this worked. Okay, so it's now a couple days later and I've just rerun the retrieve fine-tune function. I made sure to save that ID just so I didn't lose track of it. And it looks like it has finished running. The status now says processed, and the validation file was processed as well. And here I can see the created at and updated at times. Not sure exactly how long that took. We can check that in a moment. And here it says that this cost 48 cents, which is a lot cheaper than I was expecting. Let's try just subtracting the finish time and the start time. I'm not sure if that's in seconds, but if it is in seconds, then a little under 3 hours to complete that, which sounds fairly reasonable given that there was a queue of about 14 people. And then once it actually started, let's see how long it took once the model actually started training. 8:51. Again, if we're assuming that that's seconds, then that would have only been about 14 minutes. Let's take a look at the documentation for fine-tuning. to figure out how we can actually use that fine-tuned model once it's done being created. Here it's saying once a job has succeeded, the fine-tuned model field will be populated with the name of the model, and you can now use this model as a parameter to the completions API and make requests to it using the playground. I'm going to see if this is already implemented in the OpenAI R package. I'm going to search for completion. Interesting. Okay, so the completions API is probably the one that most people are used to using. It seems like this is where we would just pass the model that we just created and a prompt. If I go back to that example notebook from before, I can see that the data preparation tool that was run in the terminal tells you that after you've fine-tuned a model, remember to make sure that your prompt ends with the same indicator string that it ended with when you trained the model. When I used the data prep tool, this wasn't the suffix that it gave me. So I'm going to pause recording this video, go back and check the one that I was recording a few days ago when I actually created the model, and I'm gonna just double check what that suffix is. Okay, so I just checked and it was a space and then an arrow pointing to the right that was used as the suffix. So if we want to be able to use the create completion function, then we'll need to make sure to include that as well. First, I'm going to try it on an example of just one prompt to make sure that I can get the syntax working correctly. So I'm going to go back into that folder before. This time I'm going to go into the test data, and I'm just going to pick a random one. Let's pick a positive one, and I'm just going to scroll and click on a random one of these. I'm going to copy and paste that prompt, and then I'm going to paste it in here again, making sure that I leave room for that suffix, which is the space and then the arrow pointing to the right. So I'm going to paste that in there. And then I'm going to, instead of putting this in quotation marks, we're going to use a raw string. So that's the letter R, open quote, open bracket. And then here we're going to close the bracket, close the quote, and then that runs just fine. And now let's try using the create completion function to actually use that model that we created. For the model argument, we'll need to pass the name of the model here. So I'm going to run retrieve fine tune again. And it looks like this is the name of the model. And let's just pop back over to the documentation for a second. Here we can specify the prompt. And then there's also an argument for suffix. It's not really clear to me whether or not we need to explicitly put that space and the arrow, or if the suffix argument would just append that suffix to the prompt that we give it. It's also worth noting that the suffix argument was part of the create fine-tune function as well. And again, I'm not sure whether what the suffix argument does is append that to every string, or if it's a way to tell the function to explicitly look for that suffix in each of the strings. I'm going to try it without specifying the suffix, and we'll just see what happens. Next, I'll specify the prompt. I'm going to use my prompt, and likely everything else we can just leave as the default for now. It's already going to be able to find our API key. So let's see how this does. And remember, we used a positively labeled example from the test data. And let's take a look at my results. So if we look at the my results object, and then we go to the choices and then text, let's see what it did there. So it seems to have guessed it right, although the results that it's outputting are a little bit strange. Let's see if we add in a couple more arguments to the create completion function, if that makes it a little bit easier. So this time I'm going to specify that the suffix is a space and then an arrow pointing to the right. And I'm also going to lower the value of max tokens, because right now by default it's set to 16. And as far as I understand from the OpenAI API documentation, a token is approximately more or less equivalent to one word. So if it's expecting that it can return up to 16 words to us, and that might explain why it's giving such a long response there. And I'm also going to take a look at the documentation directly for fine-tuning as well, and just see if there's anything that I'm missing once the model's been trained. So if I take a look at the example notebook, it looks like we should actually be setting max tokens equal to 1, and we want the temperature to be as low as possible. So let's try making those changes. I think because I've already specified the suffix in the prompt itself, I don't need to specify the suffix argument. Just based on this example here, it looks like they're taking the prompt and then they're appending the suffix. So I don't think I need to specify it again, but let's change max tokens to be equal to 1, and then we'll change temperature to be equal to 0, and we'll rerun that. And this time it does return positive. And now if we wanted to loop over all of the prompts, it would be fairly easy to just repeat this script, but change the training to test. And then I believe that this function is likely vectorized, so you could probably just loop over a vector of prompts. But just to confirm that, let's try passing more than one prompt and seeing how that goes. So this function is already vectorized, so you could very easily just pass as many prompts as you want, or pass, for example, a column of a data frame that has the examples that you'd like to perform classification on. So overall, creating this model was really easy. It only cost 48 cents. That being said, we did subset down quite a bit to only use 5% of the original training data, but even still, that would only have cost a little under $10 approximately if we had trained on the entire training data. I'm not sure how many hours it would have taken to train, but overall a pretty reasonable price for creating your own fine-tuned model. And then using the model is really simple as well. And if we check the overall usage for this project, it was 48 cents a couple days ago when the model was trained, and then today generating the responses for those prompts was actually so cheap that it just rounded to 0 cents, or maybe 1 cent it looks like, but still fairly affordable. Thanks so much for watching this video. I hope you enjoyed it. If you haven't already done so, please subscribe to my channel so that I can keep making more videos like this.